Hey guys, how you doing? In the earlier video, we talked about functions. In this video, let's talk about anonymous functions or function literals or a lambda expression. People use three different names, but essentially all of them are the same thing. I prefer calling them function literals.
Any specific reason?
Yes, there is a reason. Let me explain. One of the basic ideas of functional programming is that the functions are the first-class citizens. They are like values. So, whatever you can do with values, you should be able to do it with the functions, right?
Yes, that's correct. We can assign functions to a value. We can pass them as a parameter and we can return them from a higher order function.
Yes, you already learned that. We can also create values using a literal. For example, I can create a string value like this, an integer value like this, right? I created a value s using a string literal. Then I created a value l using an integer literal. By default, it's an integer, but I can specify the data types like this. Another alternative for enforcing the data type is this. Now, let me ask a question. Can you create a function value using a literal?
That's an interesting question. If we create a string value using a string literal, we must be able to create a function value using a function literal.
Yes. And here is the syntax for creating a function literal. You can compare it with def syntax. You will notice three differences. You don't have a function identifier. A right arrow symbol replaces the equal to sign. The return type moved to the end.
Yeah, that's correct. I think the comparison is an easy way to remember both the syntaxes.
Right. Let me apply this syntax and create a function. It is exactly same as we created a value earlier, right? Instead of using a string literal, we use a function literal. That's it. I skipped the return type for this function value because Scala automatically infers the return type. However, you can enforce it by putting it in the end.
I have a question. We created a long value. We were able to specify the type annotation here. Can we do the same with the function literal?
Yes, you can do that. But you must remember the difference between these two places. In the end, I mean at this place, we define a return type of the function. However, at this place, we specify the type of the function that includes the input type and the return type both. The input type is a single integer and the output type is also an integer. That's it. But you should avoid this part because Scala should be able to infer that automatically. Let me give you a quick question for practice. Create a function value that takes two parameters, an integer and an string. The function should return another string by concatenating the string around the integer. Here is an example of input and output for your better understanding. Use the complete function literal syntax.
Okay, let me try. Here it is.
Great. My fun is the value. This part is the function type. This part is the function literal. The equal to separates the value definition and the function literal. But I recommend removing the optional parts. So, remove the function type and the return type. This is how you should be creating a function literal. I hope you got the function literal syntax.
One quick question. We learned some other optional parts in an earlier video, such as semicolon, return keyword, curly braces. Are those rules also apply to function literal?
Yes. Since function literal is just another syntax to define a function, everything that you learned about functions also applies to the function literals.
It's nice to know the function literal syntax. But where do we use them?
That's a good question. Most of the time, you will use function literal with higher order functions. I mean, either you will be passing it to a higher order function or returning it.
Can you give some examples?
Yes, let's take a list of customers. You want to convert these names in proper case. You can do it by applying the following function on each element. So, you pass this literal to the map method. Another example. You have a list of some numeric observations. Normalizing your data is a common activity in statistics. You want to normalize this data between 0 and 1. You can work out your normalization function and pass it to the map method. Passing a function literal to a higher order function is a popular thing in Scala. You will see it all over.
I have a question. Can you explain a little bit about map method? How does it work?
Okay. We will talk about map method and some other similar things in a separate video. But let me give you a quick explanation. The map method is a higher order function, right? It takes another function and applies it to each element of the collection. So it's like a loop. Since you have 10 items in the collection, the loop will execute 10 times and apply the function literal. Every time it will pass one element from the collection to complete the call. It will collect the outputs of all 10 calls, create a new collection and return it. That's it. There is an important observation in this example. We know that the x must be an integer because we are working with a collection of integers. If you try to make the x as double or any other data type, Scala will complain about the type mismatch, right? With this knowledge, let me highlight another optional item here. Scala tries to infer the type whenever and wherever possible. In this example, Scala knows that the data is a list of integers. So the x must be an integer. Hence, the type annotation for the function literal becomes optional. When you have a single input parameter and Scala can infer the type, you can also leave the parenthesis around the input parameter. However, you must remember that the parameter type inference is not always possible. It is only feasible in some cases like in this example, because Scala knows that you are applying a function literal to a list of integers. Great! We have seen a syntax for creating a function literal. In fact, the function literal is syntactic sugar for the def syntax. We can represent every function literal using a def syntax. Great! Here is the list of key takeaways from this session. A syntax for creating a function literal is like this. You can assign the function literal to a value. You can also specify the type of the function value, but remember to specify the full type, input type and output type. The type annotation for the arguments of a function literal is optional when you are working with a higher order function on a collection. When Scala can infer the type, a pair of parentheses around the single input is optional. Great! Thank you for watching Learning Journal. Keep learning and keep growing.